Hello students, and welcome to our lesson on applications of solving equations. Today we're mostly just going to be dissecting word problems, turning them into equations, and then solving said equations. But the real key focus is on turning the words into the mathematics. So we have a couple steps we're going to be taking. What we want to do whenever we're presented a problem, of course, is to read that problem. Believe it or not, I have to say that. So please always read the question. If you don't read the question, you have no idea what you're answering. Just like you should listen when people are talking to you, you should read the problems presented to you. Then we want to mark up the text. So by mark up the text, we mean annotate, which is underline, highlight, etc. We just want to pick it apart in a way where we can diagnose what each word is representing. So you're going to see me use a lot of colors in this lesson, where I will try to color code where everything I write down is coming from. Then we want to get organized. So we want to organize the information given to us. So either make a list, draw a picture, or sometimes there's really not a great visual that is necessary. So sometimes we actually skip the organization step. But even if we're not going to draw a picture, it's always good to make sure we've at least thought about what each thing represents. All right, then with all our information we're given, we want to write an equation that represents the situation or the scenario. And by represents, another word we might use is models. Okay, so we either want to represent or model the scenario using an equation. And once we've done that, then the hard part really is done. Then we just get to fall back onto our skills from previous topics. We want to solve and make sure that our answer actually makes sense. Okay, and by actually makes sense, a lot of times word problems, we're going to be dealing with real world applications. So if you're solving for time or a distance and you get a negative number, a lot of times that's not going to make sense. So even though you did all the mathematics correctly, you might wind up with a solution that doesn't actually fit the scenario all that well. Most of the time, though, whatever answer we get to is going to be correct. There's only a few circumstances early on where we're going to have to throw answers away. But as you go deeper and deeper in mathematics, you'll learn about various functions. And in those different functions, you have restrictions where the input can only be certain things. So I won't go too into the weeds, but the key is just to make sure at the end of the problem that your answer makes sense, which usually means say your answer out loud in the context of the question, and if what you just said makes sense, then your answer is probably valid. All right, so let's take a look. 5 times the sum of 3 and twice a number is 70. We want to find the number. So what I always like to do first is diagnose what is the question. So in this case, find the number is what we're trying to do. So the question really is, what is the number? Since we don't know what that number is, we assign it a variable. So when it says find the number, we're going to say that n is that number. All right, so now we got all this crazy word in the beginning. It says 5 times, so 5 times the sum of 3 and twice a number is 70. Oh my gosh, there's a lot going on there. Okay, so 5 times. What does 5 times mean? It means we're going to be multiplying. So 5 times is, oops, wrong color there. 5 times is going to be 5 multiplied by something. And then it says the sum. Well, what does the word sum mean in mathematics? It means to add. Okay, and what are we finding the sum of? We're finding the sum of 3 and twice a number. Okay, so when we say we're finding the sum of 3 and twice a number, that means 3 plus, where the plus is that same plus sign from over here. So 3 and twice a number, the sum of 3 and twice a number is 3 plus 2 times whatever that number is. So it's going to be 3 plus 2, and then we're going to put n there because our variable is n. All right, that was a whole lot of craziness. So let's summarize that real quick. We have the sum of 3 and twice a number. The sum of 3 and twice a number is 3 plus 2n, where it's the sum of, so we add together 3 and twice a number means double that number, so 2n. But in front of that, we have 5 times that sum. So we're going to do 5 multiplied by that sum. And our last part over here, it says is 70. The word is in mathematics means equals. And then 70 is just a number, so we just copy down 70. So down in our equation, we're going to have 5 multiplied by 3 plus 2n is, which means is equal to 70. That's the hard part. Now the hard part's out of the way. Now we just have to solve for n. So we can go ahead and start by distributing on both sides to get 15 plus 10n is equal to 70. Then we want to isolate the variable, so we subtract 15 from both sides to get that 10n is equal to 55. And now we divide both sides by 10 to get that n is 55 over 10. And 55 over 10 is going to reduce to either be 11 over 2, or that is 5.5. So we can write our answer in one of two ways. We can either say n equals 11 over 2, or n equals 5.5, where here n is the number that we were trying to solve for. So two possible ways we can write that answer. All right, number 2. 2 more than a number is 12 less than 3 times the number. And it says find the number again. So I always again like to start with, what am I trying to do? I'm trying to find the number. I don't know what it is, so let's call it n. Now, usually when I diagnose these problems, I try to split it into two sides of the equal sign. So in this problem, we have 2 more than a number, then it says that word is. So I stop highlighting generally when I get to the word is, because I know that is means equals. So I'm trying to find out what is on each side of this equal sign. On the other side of the word is, we have 12 less than 3 times the number. So notice the green underline on the left and the blue underline on the right are going to make the two sides of my equation. So now that left side says 2 more than a number. If that number is n, then 2 more than a number is n plus 2, where we just take our number and we add 2 to it. On the right side, it says 12 less than 3 times the number. 3 times the number is 3n, and 12 less than that is 3n minus 12, where once we get 3n, we then take away 12 from it. All right, now we have our equation set up, so now we can go about solving. In order to solve, we're going to get all of the variables to one side and all of the numbers or the constants to the other. So I'm going to move 12 to the left by adding 12 to both sides. So I'll get n plus 14 is equal to 3n because I added 12 to both sides there. Then we're going to move the n to the right by subtracting n from both sides. So we get 14 is equal to 2n. And now to get n by itself, we divide both sides by 2. And so we get that n is equal to 7. So then we can summarize, when n is equal to 7, we can say that the number is 7, where the number was our n variable. And to be clear, in the first problem, if we wanted to be extra explicit, we could have said that the number is 11 over 2 or 5.5. But as long as we've defined our variable, so we've made it clear what that n variable is, then we're okay either way. But it is good here to say that the number is 7 as a way to finish off our problem. All right, based off those two, you guys go ahead and try the you try one. Give you a second to pause the video there. All right, hopefully you paused. So now let's go ahead and dive into this. It says 3 less than twice a number is 19. Find the number. So when it says find the number, that's the n that we're looking for. So since we don't know what the number is, we just call it n. We give it a variable. And then it says 3 less than twice a number. We see that word is always means equals. And we see 19 on the other side. So I can go ahead and just copy down the 19 because that's just a number. But on the left side, 3 less than twice a number. Well, we don't know what our number is, but we called it n. So twice a number is 2n, and 3 less than that would be 2n minus 3. So the left side of our equation is 2n minus 3, the right side is 19, and this one is nice and easy to solve. We just have to add 3 to both sides to get that 2n is equal to 22, and then divide both sides by 2 to get that n is equal to 11. So we can then conclude that the number is 11. All right, let's go ahead and move on to the back side. Now we're going to make things a little bit more complicated. We have that a patient receives 3 doses of a medication over 3 days. The total dosage administered over the 3 days is 96 milligrams. If each day's dose increases by 1 milligram, how much medication did the patient receive on the first day? So what we're actually trying to answer here is all the way at the end. How much medication did the patient receive on the first day? So since we don't know what the answer is, we will call that amount of medication X. And because our units in this problem are milligrams, I'm going to write X milligrams is going to be what I'm trying to find. All right, so now a patient receives 3 doses. So we know that there will be 3 doses in total. And this happens over the course of 3 days. We don't really care that it's happening over 3 days, other than the fact that we know that it's 1 dose each day. So when we solve for how much medication the patient received on the first day, we know that that's equal to whatever the first dose was, because they only get 1 dose per day based on the fact that they have 3 doses over a 3-day period. Okay, so when it says 3 days here, well, let me use a different color. This 3 days is hinting, or at least making us think, that this is 1 dose per day. So now it goes on to say the total dosage administered over the 3 days is 96 milligrams. If each day's dose increases by 1 milligram, then we can go ahead and solve for how much the patient received on that first day. So each dose increases by 1 milligram. What that means is that whatever the first day's dose is, the second day's dose will be 1 higher, and the third day's dose will be even 1 higher than that. So we can start off with not knowing what the 3 doses are. We're going to have X on day 1, Y on day 2, and Z on day 3, where all together this is supposed to add up to be 96 milligrams. So to be clear, I'm going to write these in blue, the X, Y, and Z, where the fact that there's 3 doses and a total of 96 milligrams means that the 3 doses X, Y, and Z have to add up to be 96. But now we're going to use the fact that each day's dose increases by 1 milligram. So if we give X as our dosage the first day, then on day 2, we're going to give not some random amount, we're going to give 1 milligram more than X. So we're going to give X plus 1 milligrams on day 2. And then on day 3, we're going to give 1 milligram more than that. So if we give 1 milligram more than X plus 1, that would be X plus 2. So for example, if on day 1 we gave 1 milligram, then on day 2 we would give 2 milligrams, and on day 3 we would give 3 milligrams. We call these consecutive integers because consecutive means in line, and we are increasing by 1 each time. So we're just going 1 up the line. All right, so now we have our equation, and notice that we only have 1 variable in our equation. So you know you have things properly set up when you only have 1 variable to solve for. And in this case, our X represents exactly what we want to find, which is how much medication the patient received on the first day. So we can go ahead and solve now. If we combine like terms on the left, we have 3 x's, and 1 plus 2 gives us 3. So 3x plus 3 is going to be equal to 96. We can subtract 3 from both sides to get 3x equals 93, and divide by 3 to get that x is equal to 31. So what that tells us is that on day 1, the patient received 31 milligrams of the drug or of the medication. All right, if the patient had received more than 1 milligram increase per day, then we would have just changed this x plus 1 and x plus 2 to reflect that. So for example, if it said the dose increases by 2 milligrams per day, then we would have had x plus 2 and then x plus 4 because we would just add 2 each time. So however much it's going up by, we can just add that amount to x to get to the consecutive terms. So on all 3 days, we gave the patient 31 milligrams, and then 32 milligrams, and then 33 milligrams for a total of 96 milligrams. All right, some geometric examples now. A rectangular hospital room is being prepped for a new patient. The length is 3 meters more than twice the width. If the perimeter is 54 meters, what are the room's dimensions? So because it's asking us for the dimensions of the room, and we know that the room is a rectangle, the first thing I want to do is sketch this rectangle. So when it says what are the room's dimensions, we want to know length, which I'll call L, and we want to know width, which I'll call W. Okay, because the dimensions of a rectangle generally we refer to as length and width. You can call it base and height, but it's going to mean the same thing. So since we know the room is shaped like a rectangle, we'll sketch a rectangle real quick. And then we have dimensions to this rectangle where usually we write W on the bottom and length on the side. All right, but now we have a little bit more information. We have that the length is 3 meters more than twice the width. So if our width is W, we can write an expression for length 3 meters more than twice the width. Twice the width is 2W, and 3 meters more than that would be 2W plus 3. So we can claim that W is just W, okay? The width is just the width, nothing crazy. But the length is actually 2 times the width plus 3, or 3 meters more than twice the width. So then it goes on to say, if the perimeter is 54 meters, what are the dimensions? So now that we have an image to go along with our thoughts here, we just have to use a formula for perimeter, and then we can go ahead and solve for our length and width. So perimeter is what you get when you add together all of the side lengths. So if I add together all 4 side lengths here, make sure you understand that because it's a rectangle, opposite sides are equal. So on the top we have W, and on the left we have 2W plus 3 again. If I add together all 4 sides, we're going to have W plus W, where those 2 W's are the bottom and the top. And then we're going to have the 2 lengths, which are 2W plus 3 and 2W plus 3, where each 2W plus 3 comes from the left and right side. So now we have that this is equal to 54 meters. So I can set my perimeter equal to 54, and I can go ahead and label this left side as perimeter. That way I know where this is coming from. So our perimeter needs to be 54 meters. We can go ahead and combine like terms now. We have 6W plus 6 on the left side. So then we can go ahead and solve. If we subtract 6 from both sides, we get 6W equals 48. And if we divide by 6, we get that W is equal to 8. And our units here are meters. So now, based on the fact that W is 8, we can also solve for the other side length, where we take this W being 8 and we plug it back in to this length formula. So we can then say that the length is equal to 2 times 8 plus 3, where I'm plugging in my W to this formula, so I get the length is 16 plus 3, which is 19. And so in total, we have that the length, or we can say the room is 19 meters long and 8 meters wide. And we can always double check that this answer makes sense by just plugging it back in for our side lengths and checking with our word problem. So if we have that the length is 3 meters more than twice the width, then 8 times 2 plus 3 does give us the 19. And we can double check that 8 and 19 make a perimeter of 54, because if we add together two 8s and two 19s, we are going to get 54 as our perimeter. All right, number 5. The triangular warning sign on a biohazard container has angles in the ratio 1, 2, 3. What are the measures of the three angles? So they're in ratios of 1, 2, and 3. That means if our first angle is A, then our second angle would be 2A, and our third angle would be 3A, where the ratios correspond to the multiples that take us from one angle to the next. So if we have a triangular sign, so I'll just sketch a rough triangle, we're going to have one angle, that's A, one angle that is double A, and one angle that is 3 times A. So now we need to have a formula that relates the angles in this triangle to what the angles in a triangle actually add up to, which we need to know that angles in a triangle add up to 180 degrees. So based off of the fact that this is a triangle, we can go ahead and say that 180 is equal to these three sides, or these three angles added together. So A plus 3A, A plus 2A plus 3A. Technically, it was right if I put the 3A first, but nice to keep them in order. So again, in a triangle, all sides add up to 180. So I keep saying sides. All angles add to 180 degrees in a triangle. So we can go ahead and solve our equation now. We have that 180 is equal to, if we combine the a's, we get 6a. So then if we divide by 6, we're going to get that a is equal to 30. Now we can check what the other two angles are by just substituting in a equals 30 to 2a and 3a. So if a is 30 degrees, then we're going to get that the second angle is 60 degrees because we do a times 2. And then we'll get that the third angle is 90 degrees. So our three angles are 30, 60, and 90 respectively. And just because we have a little bit of knowledge about triangles, the fact that 90 degrees was one of our angles means we actually had a right triangle to start with. And so our picture should have, if we had this information at the beginning, looked like 3A is this right angle, 2A would be the top angle, and A would be the angle on the right side. So it's not that our picture was necessarily wrong before, we just gained information. So after solving, we can see that we actually had a right triangle, and so we can even put a right angle box over that 3A. But that's just a coincidence. We will not always get 90 degrees as one of our angles. All right, so the keys to this lesson are to carefully read the problem, diagnose what each word in it represents, and then take that and use it to solve an equation that models the situation you are referring to. All right, see you guys in the next one.